Hello friends, have you ever wondered how modern API platforms handle millions of requests securely and efficiently? Today, in this video, we will break down OpenClaw architecture into three core parts, which is gateway, runtime, and security in super simple way. By the end of this video, you will clearly understand how requests flow, how services execute, and how everything stays secure. So let's understand what is OpenClaw first. OpenClaw is an API first architecture platform designed to manage, execute, and secure distributed service. It's mainly consists of gateway, which you can consider as entry point, runtime, which consider as a execution engine, and third one is security, which is protection layer. So we can think it like restaurant. We can consider as a gateway waiter taking your order, and runtime is kitchen preparing the food, and security we can consider as manager ensuring rules are followed or not. So let's first understand the high level flow. So in the high level flow we can see here the client send a request and gateway receives it, and security validate it, runtime process it, and response goes back to the client. Simple but powerful. So let's get deep dive. Now let's zoom into the gateway. The gateway is an entry point of the system. Every request from the client, whether it's a mobile app, web app, or another services, must pass through the gateway first. Think of the gateway like a security gate at an airport. No one goes directly to the plane. Everyone must pass through the checkers, right? Similarly, in OpenClaw architecture, the gateway handle multiple responsibilities. First is the request routing. When the request comes in, the gateway decide where it should go. For example, if the request is uh, users slash user, it route to the user service. If it's a order API endpoint, it goes to the order service. Second is a rate limiting. This prevents system overload. Imagine if one user send 1,000 requests per second. Without rate limiting, your system would crash. So the gateway restrict how many requests are allowed. Then third is request transformation. Sometimes clients send the data in different format. Like the gateway can modify the header, add metadata, or even transform the payload before sending them forward. And the fourth is logging and monitoring. Every request is tracked, which helps in debugging and analytics. Let's let's zoom into the runtime. Once the request passes through the gateway, it reaches the runtime, the place where actual work happens. If the gateway is the entry gate, then runtime is the engine of execution. This is where business logic lives. The runtime is responsible for execution application logic, calling multiple services, fetching and processing the data, and returning the final response. Let's understand this with a real example. For example, get user dashboard. When user open their dashboard, you don't just fetch one thing. You need the user profile, recent order, notification, and recommendation. The runtime orchestrate all of this. Here what happened internally. It called the user service, then order service, then notification service, maybe even recommendation engine. Each service responds separately. Then runtime combine all the responses into one single structure response and send back. This is called service orchestration. Another key responsibility is data transformation. Different services may return different format. Runtime standardize everything into a clean response. Runtime is designed to be scalable. If the traffic increases, more runtime instance can spin up, load get distributed. So performance remains the stable. In simple analogy, we can consider that if gateway is a waiter, runtime is a kitchen where multiple chefs prepare different dishes and combine them into the one meal. Let's talk about one of the most critical part, which is security. Without security, your system is exposed to unauthorized access, data leaks, and attack. In OpenClaw architecture, security acts like a protective shield between gateway and runtime. Before any request is processed, it must be verified. There are three major components of security. First is authentication. Authentication means who are you? When the user logs in, they receive a token, usually a JWT token. Every request must include this token. Security layer verifies, is the token valid? Has it expired? If not valid, request is rejected immediately. The next component is authorization. Even if the user is authenticated, they may not have a permission for everything. For example, admin can delete user, normal user cannot. Security checks rules and permission before allowing the access. Next is authorization. Even if the user is authenticated, they may not have permission for everything. For example, admin can delete a user, but normal user cannot delete it. Security checks rules. Basically, security checks the rules and permission before allowing any access. The next we can take it as data protection. Sensitive data is encrypted in transit, which is HTTPS, sometimes even at the rest. This prevent data leaks. Now let's walk through the real example. First, will user logs into the app, then send request with a token, and gateway receive the request. Once request is received on gateway side, security validate the token and runtime process the logic, and then after that response is returned. This entire flow happens in milliseconds. To summarize, gateway manage incoming traffic, runtime execute business logic, and security protects everything. Together, they create scalable, secure, and efficient system. If you found this video helpful, don't forget to like, share, and subscribe. Thank you.